A study was done on body temperatures of men and women. The results are shown in the table. Assume that the two samples are independent, simple random samples selected from normally distributed populations, and do not assume that the population standard deviations are equal. Use a 0.01 significance level and test the claim that men have a higher mean body temperature than women. So the claim is that men have a higher mean body temperature than women, so mu1 would be bigger than mu2. So if we do this problem in statcrunch, then we'll click Stat, tstats, toSample with summary, since we have all of the measures in a table. So sample 1 will be the men, as it is designated here in the table. And the sample mean for group 1 is 97.77. The sample standard deviation is 0.97. The sample size is 11. For group 2, the sample mean is 97.25. The standard deviation is 0.65. And the sample size is 59. The problem told us to not assume that the population standard deviations are equal, so we will uncheck the pool variances box. The problem asked us to test whether or not the mean body temperature for men is greater than that for women, so our alternative hypothesis then would be greater than mu1 minus mu2 greater than 0. Now we'll click Compute, and this output box gives us everything that we need. The test statistic is 1.71 if we round to 2 decimal places, and the p-value is 0.057. State the conclusion. What we'll need to do here is look at our significance level is 0.01. Our p-value is 0.057. If the p-value is less than the significance level, or in other words, if the p-value is less than alpha, then we would reject the null hypothesis. But that's not the case here. The p-value is greater than alpha, so we will not reject the null hypothesis. So our choice will be fail to reject the null hypothesis. There is not sufficient evidence to support the claim that men have a higher mean body temperature than women. Now we are to construct a confidence interval suitable for testing the claim that men have a higher mean body temperature than women. Now what we have to consider is that this was a one-tail test with 0.01 as a significance level. That means that entire significance level is in that right tail. Now if I want to construct a confidence interval, then I would have to have a confidence level of 0.98. That would put 0.01 in the upper tail and 0.01 in the lower tail. So we'll click Stat, tstats, toSample with summary. The sample mean again for group 1 is 97.77. The standard deviation is 0.97. The sample size is 11. The sample mean for group 2 is 97.25. The standard deviation is 0.65. And the sample size is 59. Remember that the problem told us not to assume that the population standard deviations are equal, so we'll uncheck the pool variances box again. Now, the problem gave us a 0.01 significance level for a one-tail test to the right. That means that 0.01 would be in the upper tail. If we want to construct a confidence interval with 0.01 in the upper tail, that means we would also have 0.01 in the lower tail, which means that our confidence level would then be 0.98. So we'll click Compute, and we'll get a lower limit of minus 0.299 and an upper limit of 1.339. Does the confidence interval support the conclusion of the test? That answer would be yes, because the confidence interval contains 0. Since that confidence interval contains 0, then it cannot be concluded that there is a difference between these population means.